Hello friends, today I will discuss the star delta starting method to a three-phase delta connected squirrel cage induction motor. To analyze this, the initial condition for the stator of the delta connected squirrel cage induction motor is that the windings of the stator have the facility to connect in star or in delta. Suppose when they are connected in delta, A1 and C2 should be joined together and C1 B2 should be connected together. Similarly, B1 and A2 should be connected together and these lines will be connected to the RYB supply lines. Similarly, to get the star connection of the stator winding, B2, A2, C2 will be connected together, and whereas B1, A1, C1 will be connected to the main supply RYB lines. In this method, there are two things that are to be found. What is the starting current when the stator winding is connected in star form first, and then from that calculating that starting current in terms of the rotor short circuited current when applied voltage is rated value. Once we know this will be substituted in the full load torque and the starting torque ratio, and then the simplified equation will give the starting torque in terms of the full load torque. So it can be observed here, these are the R, Y, B. C1, B1, A1 connected to the RYB always. And for that winding, if C2, A2, B2 are connected respectively to the C1, B1, A1 like this, then delta connection will be formed. Suppose this C1, B1, A1 are connected to RYB, which are always connected to RYB supply lines, and B2, A2, C2 are connected together, then this forms the star connection of the stator winding. In this method, star connection will be done first and then delta connection is used. The necessity of the star connected winding in the delta connected squirrel cage induction motor is that to reduce the initial current to a safe value. Let us see the diagram with the windings like this. These are the three-phase AC supply and A1 is connected to the B phase of the supply and C1 is connected to the R phase of the main supply, and similarly B1 is connected to the Y phase of the main supply, and here the other side windings terminals, that is B2, C2, A2 are connected like this. So here is the star form. Initially this B2 is connected to this and A2 is connected here and C2 will be connected here. Once that is connected like that, then the motor draws a current, and under star connected system the phase voltage is line voltage by root 3, whereas for delta connection line voltage is equal to phase voltage and the current that flows will be full load current. And ISC is nothing but the short circuited rotor current when rated voltage is applied, that can be defined like this. ISC is equal to VL by Z. So here V is shown, this V is nothing but line voltage. So when the stator winding is initially connected in the star form, the initial starting current is given by the phase current line voltage divided by root 3. That is phase voltage will be obtained by dividing the line voltage with root 3, and the per phase impedance is Z, so divide this voltage VL by root 3 with Z, then the equation will become like this. This VL by Z will become ISC, and this 1 by root 3 will be as it is like this, ISC by root 3. That is, when the stator winding of the squirrel cage induction motor is connected in the star form, the initial starting current is given by ISC by root 3. Next, there is a standard equation for starting torque and the full load torque ratio. That is, starting torque divided by full load torque is equal to starting current by full load current whole square into full load slip. So having known the starting current, it should be substitute here, that is ISC by root 3, and full load current is as usual its standard value under delta connection. So rated voltage will be applied under running condition to the delta connected squirrel cage induction motor. So once it is simplified, we get like this: 1 by root 3 whole square means it will be 1 by 3 into ISC by IF whole square into SF. So this ISC by IF can also be written as A. So if ISC by IF is replaced with A, that is ratio A, then the equation will become starting torque divided by full load torque is equal to 1 by 3 into A square into full load slip SF.